Hello, thanks for watching School of the American Rifle instructional video. I'm going to show you the way that we install AR15 fire control groups. We have several types here. We have a Geissele SSA-E, we have a LaRue MBT, and we have a factory fire control group. We have several tools and gauges laid out. I'm going to go through the procedures that I use when checking things before I do an installation. So first thing we're going to have to do is unpack all of these. So I'll take out the LaRue trigger, hammer. We'll take the Geissele trigger. Comes a little bit of go juice, some instructions, some VCI paper to prevent corrosion. We have the hammer, trigger, and the slave pin. All right, first thing we want to do, depending on whether or not your fire control group is new, or in this case used, we want to take the assemblies apart and we want to check to make sure that everything's in spec. Just because it is a name brand trigger or you paid a lot for the trigger doesn't mean that it is not possible to have a trigger that slipped through the quality control process or just simply didn't have any. So what we're going to do is we're going to look at some parts that are out of spec. We're going to look for that in our kit. So first things first, we want to take the hammer spring out, and this varies depending on the fire control group. And then what we're going to do is I'm going to find some springs in here. So what we have here are a couple examples of bad springs. So if you look at them, you can see that this isn't completely level. So this spring in here is what I would consider good. The legs are almost level with each other, where these, they bend to give a little more spring tension. And then you have these springs here, which do the opposite. They're bent in a way that either from wear or from someone bending them to try to get a lighter trigger pull. So you're going to look at the hammers in the kits. These are ones that I wouldn't use. The LaRue has a slightly different look to it, but again, hammer legs pretty much level. You can see they're not quite level there. Slight variation in the spring, but that's okay. And then over to the Geissele. Again, I'll take the spring off. You're not going to hurt the spring by giving a little bit of a bend there. And again, hammer springs almost level. So we don't want to see something like this. Something like that would be okay. And something like this may even be okay. But you just don't want it to be drastic, like I have here with these examples. What will happen here is they either will not have enough tension to maintain consistent ignition, or they won't retain the trigger pin when it's resting in the groove because there's not enough tension. We have a couple things that can happen there. As far as the triggers go, trigger spring. So if I can hold on to stuff. This is what I refer to as a good spring. It has a little bit of positive tension. This would be neutral, and this would be negative. So this is okay, that's bad. So what we'll do is we'll go through our triggers here, and I'm going to pull these off. And I'll show you why in a few moments. They're parallel, that's fine. they're parallel. And these have a little bit more tension to them, but that's okay. All right, so all of our springs check out, and we have the parts, for the most part, disassembled. One important thing that I like to cover is the removal of the hammer and trigger pins if they're pre-installed when you purchase a kit from any company such as LaRue or even Geissele. The pins will come installed in the hammer. So in cases like this, it's pretty common for people to just grab a steel punch, because when you push on these, they tend to grab on the J-spring, so they're hard to get out. So people will grab a steel punch and go putting pressure on that, and it's possible that they can either damage the ends of the hammer or trigger pin, and it can also scratch or gouge the finished surface on the inside of the hammer and the trigger. And it's far from optimal to score up the inside of something that is a precision fit. So what I prefer to use is a brass punch. You could even use something that's made of nylon or a polymer, but if you slip, it's softer than the steel and it shouldn't cause any significant damage. And then just push the pin out. Low risk of damage. And if you happen to mar the end of the punch up from repeated use, you can just take some emery cloth or a file and just dress the edge so there's not any sharp or jagged edges as you're trying to use the tool. The next thing we want to check for is we want to check for magnetism. So what I have here is a washer that I painted it orange just so it's easy to find. When I do classes, I put them in bins. They're hard to find. And what you want to do is just take your fire control parts, something this ferrous that you know a magnet will pick up. You just want to check all the parts. If it's magnetic, it'll pick the washer up. And we're only checking the parts that actually spin, move. The reason we want to do that is because any moving part in the firearm that's magnetic is going to attract particles. Either particles via wear, or maybe if you're shooting some imported steel cased ammunition, it's possible that it can shave some of the material from the casing or the bimetal jacket and start sticking to anything that's magnetic. Usually when you get these pins, they're installed already on the Geissele. Take the disconnect out. Try that. Everything looks good. So we can set that aside. In cases where you run into any of your fire control parts being magnetized, you have to have a de-magnetizer, and I can show over here on my main workbench. This is the de-magnetizer. So if any of these parts were magnetic. You would turn this on. You'd run the items across several times, and if it had any magnetism to it, it'll remove that. Next thing we want to look for, depending on whether or not our fire control group is new or used, is we want to examine the pins. We want to look for any kind of burrs, any deep gouges, any chips. And what you can do to ensure they're level is you can find a true surface somewhere in your house, something that you know is level. So right here I have a piece of granite, and you can roll the pins. And the purpose of this is to check and see if they're bent. So if you were to roll this on a surface and it's bent, instead of it rolling true, it would just move a little bit and then wobble or come to a stop, and you'll see it. Those are good. And the Geissele. Good. Of course, you need to make sure there's not a bunch of storage grease or any kind of heavy lubricants on them. They're not going to spin or roll. Here I have some examples of bad parts, and it may be hard to see in the video, but it has a chunk here missing from someone driving it in, either without lubricant or things were sized improperly. And then I have some in here that are broken. Of course, you shouldn't see that in a brand new kit, but things that I show people to look out for, and they usually break where the groove is cut. All right, next step, we want to ensure that the bores for the hammer, the disconnect, and the trigger are properly sized for the hammer and trigger pins. But before we do that, depending on who manufactures the fire control group, they can have some storage grease on them. They can get pretty sticky over time. It's just to prevent corrosion as they sit in the warehouse or when they're being shipped somewhere, or even after you purchase them and they sit on a shelf for a while. What I use is just cheap brake cleaner from the auto parts store. You can use something like gun scrubber, costs a little bit more. Gun scrubber is safer for some plastics and polymers. So what I'll do is I'll just take, and you have to be careful with this stuff if you have sensitive skin. It's prudent to wear gloves, something to prevent the solvent from making contact with your skin. But what I'll do is I'll just, and you're not trying to really degrease everything, you just want to get the grease out of the bore. Excuse me if it seems like I'm missing. But having a camera in front of your face can be a little bit difficult. Performing a task and shooting a video at the same time. So we've degreased those. On the LaRue, the disconnect is held in with a rivet, so we don't take that out. You can see some of the grease came out on the paper towel. All right, once we have those components degreased, what I normally do is I will use these gauges. These are gauges that I've made for my armor and build classes. Essentially, this gives me a go and a no-go side. So before I start, I'll take the go side, and you're not going to be able to get this all the way through on a hammer because there is a J spring in here that interacts with the center groove on your pin. So I just want to make sure that this goes in all the bores. And this is not something that's terribly expensive. It goes through. The spec for the go side is 0.155, and what is technically the field service diameter is 0.163. On a new fire control group, you're not going to need this. This is for heavy wear. So then we'll move over to the LaRue. And then over to the Geissele. Let's see if I can get the number so you can view this. There you go. Now, if you don't purchase some pin gauges to do that, like I said, just purchasing this 155 pin gauge would cost about $4 to $6 without shipping. You don't have to have the fancy handle. But in lieu of that, you can use your fire control group pins. Essentially, what you want to be sure of is that these pins don't bind on any of these pieces, the hammer, trigger, disconnect, and you also don't want them to bind in the lower receiver. So again, what I'll do is I will take each lower receiver, and I want to make sure that my 155 gauge goes through the holes. Now on this one, it's blocked by the Geissele bolt catch, but I can go from the other side. And again, these are relatively low round count receivers, so they're not going to take this larger field reject side. But what you can do is you can purchase additional pin gauges. This gauge is 154, so you don't necessarily need this. If it failed to allow the go gauge to go in, I would see if it was undersized by 1/1000ths. But generally what I want to know after it takes my go gauge, and again this is optional, is I want to know if it will take a 156 or a 157 pin. And this is just going to show you the variance between this Colt, this Palmetto, and this Nodax bud receiver. So this is the 156. Let's see if it will go into the Colt. And it won't. So the Colt's pin bores are exactly 0.155. The Nodax bud, I can't get it into there. And again, Nodax bud is exactly 155. And then this Palmetto, let's see if it takes it. All right, so it'll take a 156. Let's see if it'll take a 157. And it does. So the Palmetto has fire control group pinholes that are 0.002 oversized, brand new. No wear at all in the holes. Just to show you some variance. A lower is not a lower. This is a M16 field service gauge. Has a tapered tip to it. So if this was a well-used low receiver, you'd see if you can penetrate any of these holes by slightly putting a little bit of pressure on them and pushing in. It doesn't, so that lower is still okay to use. Some people get really curious about some of the gauges that I use, and these are 3 types of field service gauges that the U.S. military uses on the M16 and the M4. This is one of the older gauges. This is from the XM16. You can see that this one actually has a smaller spec for the no-go at 159. So the tips are all similar, but initially, before they collected more data, the original reject for these holes was 159. So let's take this Palmetto. It won't go. But this was the first spec. And then these are 2 different types of 163 diameter. You can see they have a bevel on the tip. And the reason this is done is it's not trying to see if the hole is completely round and taking the gauge. What it's looking for is an oblong hole. So sometimes it's possible for these holes to wear in an egg-shaped pattern. So what this does is, since these are machined down to only use this small surface here and the small surface here, if the hole gets egged out, this gauge will go into that as you spin it, if the hole is egged out to that diameter. So just wanted to show what these are used for. It's something that a lot of people find interesting. These gauges are rather hard to get a hold of. And these are the essentially the civilian versions that I've made. And then these are what these gauges here look like before they're inserted into the handle. And I have these in various sizes: 154, 155, 56, and 57. And it just tells me where I am when I'm dealing with a low receiver. Something that's important to note is not all low receivers use the 155 hole diameter. This is a Colt, and these actually have, for their normal spec, are 169. It's sometimes hard to determine just by looking at it, but these are larger diameter holes. So if you have a Colt and you're installing maybe an aftermarket Geissele that's a large pin, or you're just replacing the factory fire control group with a newer one for whatever reason, you want to make sure that the pins, again, fit like I instructed earlier. And then for the large pin, the no-go is 177. So if these holes were to get large enough to take this gauge, the low receiver would be rejected. Next step, and this is the reason that we keep the springs off of the hammer and trigger, but we want to ensure, we use gauges, but in lieu of that, you can just make sure that your hammer and trigger pins insert into the lower and freely spin. We're actually going to put the Geissele into the Colt, so we'll try that. So, hammer and trigger pins fit without any resistance or binding. So those are good. Of course, these were rather sloppy, so they're good to go as well. So now we know the hammer and trigger pins move freely in the low receiver. We want to do the same thing with the disconnect. So we take the disconnect. We want to make sure that the parts freely spin. No binding. Now when you're dealing with the hammer, since it has a J-spring in almost all good fire control groups, there are some that don't have this and it requires to use something like the anti-rotation pin or something. What you want to do is take the hammer and trigger pin and put it on each side. Don't push it past the J-spring in the middle. And just make sure that the hammer freely spins. And this is one of the reasons that I don't use anti-rotation pins. Sometimes they're the wrong size, and since they don't freely spin in the low receiver and in the hammer or trigger, what they can do is they can actually slow down the speed of the hammer, also the lock time. So you can have some inconsistencies with ignition. We're going to do the same thing with LaRue. And again, regardless of who makes the component, I check these things to make sure that something's not missed. So they're good. Now some Geissele do omit the J-spring and they use a small E-clip that clips on the side of the hammer here and retains the hammer pin under operation, but most normal hammers have the J-spring in the middle. So in this instance, we'll just put the pins in. Freely spins. Disconnect. Freely spins. Trigger. Freely spins. So let's say, for instance, that the hammer and trigger pins were binding in the lower, or they were binding in one of the fire control group parts. What would the solution be? Well, what I do is one of two things. The least invasive method when you're dealing with a lower receiver that's slightly undersized. So let's say this pin wouldn't go in. All right, it was binding. So these are made by Geissele. These are hammer and trigger install pin kits, but what they're great for is they're spec'd out for just this use. What I refer to this as oil lapping. So let's say this was tight. What I would do is I would put this pin in here, and if you had to push and put a little bit of pressure on it, that would be fine. And then I would just take any kind of gun oil, and I refer to that as oil lapping. And believe it or not, that movement right there, and the reason I'm doing it like this and not like this is because I want to maintain the bore being straight across. I don't want to lap this at some weird angle like this. So, and this is plastic, so if it hits into the lower, it's not going to do any damage. But if it was tight, that's what I would do. And then I would clean that up with some brake cleaner in case there was some debris in there. And then try it. And that would be my fix for the lower. I generally don't use any kind of serious abrasive. Now, and the reason being is because we want to eliminate the intentional wear of the anodizing off those holes. The anodizing is where the hardness lies on this lower. So if we strip these bores down to completely bare aluminum, they're softer and they're going to wear a little bit faster. Not something to be extremely concerned about, but still something to be aware of. So let's say, for instance, we could not get this pin into here. In this case, what I would do is I would take what I call a sacrificial pin, and this is one that I've used for this before. And I would take valve grinding compound that you can get from the auto parts store. So what I would do here is I would put some of the lapping compound on here, and I would do that. No power tools necessary. And then I would clean it out with some brake cleaner. I would test fit my pin again. Make sure I get this. I know it seems like we're going through a lot of checks. Some people might think these things are silly, but this is a procedure to eliminate the possibility of something minor becoming a ghost in the gun or giving you sporadic issues. So now that we still have things taken apart here, the reason that I still have the springs off is because I want to fit the trigger into the lower and make sure that this pocket here, number one, before we start, make sure that the pocket is centered. You don't want to have it where this side is really thin and this side is really thick. Because what happens is that your fire control group is off center now. On a group like this, it's no big deal because the hammer's thin, but when you get into a fatter hammer, this hammer being a little offset can bind and wear differently on the bolt carrier belly as it tries to cock the hammer. But you want to make sure that your pocket is centered. And then what I want to do is put my trigger into my lower. No banging it in with the hammer. I want to make sure that this freely moves. what can happen sometimes is either the pocket here can be too narrow, or the trigger, the stem here, can be too wide. So when you put it in, this binds on the side walls. So in an instance like that, if I put this trigger in here and it was binding and it wasn't freely moving like that, I would take a file and just make a simple pass on it, on one side and the other, to keep everything even. Clean it off with some brake cleaner, drop it back in, and try the fitting again. You don't want to sit here and take a bunch of material off with a file, or go nuts with something like a Dremel. You want to do nice controlled passes with a file. So once you get that done, you can do the same thing with the hammer. So you'll put the hammer in. And I'm only going to put the pin in halfway through. And what I want to see is this. Went all the way up in. Again, just trying to make sure everything moves freely. And again, we want to make sure that the stem here for the hammer doesn't bind when you put it into this pocket. There should be a little bit of play. So if we had a binding issue, again, what I would do is one pass with the file, try to keep it as even as possible. Another pass with the file, clean it out with some brake cleaner, and then try it all over again. So we're good with this one. This fits in there without any binding. I can't get the pin in from this side because of this bolt catch, so I'll just give it a go like this. There we go. And then finally, the factory fire control group. Good. Our next step, before we start putting our fire control groups, is I want to ensure that the bore in the lower receiver is properly sized for the safety. Now, I use gauges here, but one thing that you can do in place of gauges is you just want to make sure that your safety drops in. You want to make sure that it moves freely, there's no binding. So if you did have a bore that was binding, again, you would do somewhat the same thing that I did with the this sacrificial pin. I would take safety. You could get away with using your factory safety at first, but just put some oil in there. What you want to try to do is just lap it. So you put it in there and just move it. And then try to keep things even. Put some oil on it. And again, move it on this side. Try to go in and out a little bit. Spray it out with some gun scrubber or some brake cleaner. And again, test fit it, make sure it goes in. No binding. good. And again, good. So if I were to use the gauge, and this is a gauge that I spec'd out, my go is 0.375, and my no-go is 0.380. So if there's enough slop in this hole, it's possible that the safety can have enough slop. So if the trigger group is worn out to the point where that slop with the trigger group slop can allow the trigger to be pulled and the hammer to drop when the safety's on. So it's only 5 thousandths. So it doesn't take that, but what I do want it to do is take my gauge. It's a little bit tight in the Colt, but it does go in. And of course it's not going to take that. And just to show you a comparison, this is the military gauge, selector lever. The go side is 3758 and the no-go is 3808. And this is just one that I made. Next thing we're going to check is the screws that they come with. So this is a slotted screw with a lock washer. Another slotted screw with a lock washer. Now this Magpul grip didn't come with this screw, it came with this. And then for this one we have, again, a slotted screw and a lock washer. There's nothing wrong with the screws that the Magpuls come with. You actually run less of a risk with having the screw being too long and bottoming out with these shorter ones. But what I don't like about the Magpul and some other companies is they put this thread locker on here. It's a dry thread locker. And what you run into when you're trying to install this into a lower receiver is you put it in, and let's say you have your pistol grip on here and you get it started. So we have it started, and you can see we're about to approach the thread locker, and as you approach it, it starts to give you a good bit of resistance. If you have a lot of experience, there's nothing wrong with this, but what can happen is let's say you didn't align the screws properly, and you put it in slightly off. Well, it's possible you could cross thread this, and what you're feeling is actually you cross threading the screw instead of you being able to just easily screw it in. When you run into those dry thread lockers, you have to fight it. And the question is there something wrong with the lower? Are the threads not cut all the way through? Are they undersized? Is there something in there? Or are the threads on this bad? So what I usually tell someone to do is if they have this kind of screw, I'm going to take a brush, because this is not necessary to retain the pistol grip, and you want to remove the thread locker so you can install the grip screw without anything impeding you. And the reason we're doing this is we want to fit it before we get a grip installed on there, because you're installing it somewhat blind. And when you get the Magpul, they do not have a lock washer included because they put thread locker on the bolt, the screw. So if you do remove the thread locker, it's prudent to install a lock washer. So what we're going to do is just make sure that all of our low receivers are threaded so we can install the pistol grip screw without any kind of resistance. And all of our pistol grip screws going without any incident. Now the next part seems a little backwards because in most cases you would install your safety, install your pistol grip, and then you put your fire control group in. But on some triggers like LaRue, you're not able to get the trigger in past the safety when it's already installed. So you have to install the fire control group, and some other triggers are the same way, first, and then install your safety and your pistol grip. What you want to do is install your grip without any parts in it. So I'm going to snug down that grip screw. What we're looking for, we're going to look inside to make sure that the grip screw isn't protruding into the pocket. You want it to be below the surface, which it is. What you don't want is something like this. We don't want that. When it protrudes, it can make contact. And this is roughly how it's oriented into the lower, so the grip screw will come through the lower, and they'll normally sit about this far apart when this thing is below the surface. But if the screw's far enough, or screws long enough to protrude further up into the pocket, it can make contact with the trigger and actually push it to the rear. In some cases, this won't cause a serious issue, depending on how much contact it makes, but if it causes too much contact, it can cause the trigger not to push forward far enough to reset. So you need to look out for that when you're installing your grip screw. There is a company who makes an aftermarket screw. This is actually drilled to the center, and there's a secondary screw in here. So the principle for this is to install the screw, and then you put an Allen wrench in here, and this screw will come further out and actually make contact with the trigger. And this is to take some of the slack out of a gritty military standard trigger kit. The problem with using these is they tend to shoot loose. Either the screw here loosens up, or if you change the pistol grip, depending on how much material there is in the grip, it changes how far this set screw protrudes. But generally they're pretty unreliable. Once you set them and the trigger components start to wear into one another, you'll run into issues with failure to reset, or you'll have hammer follow. So we checked all the screws. Let's say, for instance, you have a bolt that you just can't get to start. Or you get it in a little ways in, and all of a sudden it just stops. In those circumstances, you'll have to break out a tap. And on the AR15, the lower receiver pistol grip screw is 1/4 28. And you can chase the threads. You have to be very, very careful though that if you do something like this, that you use cutting fluid, even though this is aluminum, and you would assume that it's super soft. You need to make sure that you get it started straight, and you need to use cutting fluid that's designed for aluminum. If you use regular cutting fluid, it can be corrosive to aluminum depending on the grade. But you always want to tap, back off, tap, back off, and keep doing that until you clear the threads out, and then blow all the debris out. Okay, next step, we're going to put the hammer spring onto the hammer, and this is something that many people mess up. And the way that I try to explain it to people, when you are putting your hammer spring on, you can tell if you did it right if the spring has tension when you lay it face down on the table. So I'll show you an example. Let me get down low. So if I put this spring flat down, and I put the hammer flat down, and I pick it up and just peel the legs around it, what you can get when you lay it on a flat surface is you get tension. So now I know my hammer assembly is assembled properly. But if you do it wrong, you put the spring on backwards and you lay it down on the table, look, no tension. It'll still go into the lower like this. You can peel the legs like that, and it'll actually function. It'll drop the hammer and it'll fire. It'll have a lighter trigger pull when you do this. But usually what happens is it's not enough hammer tension. And either your pins will walk out for your trigger because these legs can't properly retain them due to the reduced tension, and you'll get light strikes. Sometimes you'll even get doubles because it doesn't allow the hammer to have enough tension to catch on the disconnect. So again, if you're not even sure, and you just pick up a part and you're like, oh, okay, I'm going to put this on here. Put it on there. Oh, wrong. Take it, flip it around. Right. So we'll do the same thing to the Geissele. I'm sorry, the LaRue. Lay them both down. I have tension. So what we're going to do, since the LaRue, you have to put the trigger in before we do the safety, we're going to do the trigger install here with LaRue before we put the grip assembly on, because we have to put the trigger in. It won't bypass the safety on this particular trigger design. So one thing you don't want to do is you don't want to break out big hammers. And some people prefer to work with a low receiver block when they're doing this. So they'll put the lower in. They'll transfer it to their vise so everything's secure. It's not going to flop out of your lap or bounce and you mess up something. Not everybody's comfortable working like this. Not everybody has a vise assembly that's securely mounted to a heavy bench. But we'll go ahead and do this just for instructional purposes. You can use several different types of fixtures. This is a bow tack fixture, which is a copy of the Geissele. I have the Geissele, but I prefer this one because the Geissele is only designed for mil-spec receiver extensions, also known as buffer tubes, where this one will go on the commercial and the mil-spec. But you could lock this down and put it in your vise, and you can work on it. And what's nice about it is you can change the orientation like so. So you have straight in access. It's a pretty handy tool. It also has a secondary purpose, but it doesn't apply to this video. So, and then this gadget is essentially the same thing. It goes over the buffer tube, and you can crush it in the vise jaws, but it only will grab the buffer tube this way or this way, so you can't clock it like you can with this fixture. So what we'll do And we'll loosen this. And tighten it down. And the Geissele comes with 2 trigger springs. This is the heavier trigger spring. And this is the one that it came installed, and you can see the heavier one has a little bit more of a positive angle on it than this one. Generally, if you're not going to go through the steps that I went through of making sure everything freely spins, I advise people to use the heavier spring to overcome any possible binding you may run into. But we've already checked everything, so I'm going to use the lighter spring. There's about a roughly a pound difference in between the heavier spring and the lighter spring that the MBT comes with. So what we're going to do, drop the trigger pack down in there. And again, you want to make sure that when you have your trigger spring on, the leg goes around here, not something like this. No tension. And you don't want it like this. See, it's catching there. You want it to be like so, right in this little pocket. We're going to drop this in here. There's a couple tools and methods you can use, but what I normally tell people is you do not want to go banging on the pins. So this particular kit right here is made by Obsidian Arms. What I like about it is it comes with 2 little cheater devices. This is a little slave pin, and then it has a nylon punch that will hold the trigger pin. So what you can do here is you can come off to the side, try to line this up as close as you can, and the point will help guide everything together. And again, we don't want to go hammering on anything. And then what you can do with that in there, you can come from the other side, and I always use grease. I have Aeroshell here, and I have some Mobil 1 synthetic grease, but you can use any kind of gun grease. But whenever I'm pushing the parts together, I like to put a little bit of grease on. And then just a little bit of wiggle while you're pulling this pin out. And then it goes. Wipe off any excess grease. We'll keep this out. Make sure the trigger moves freely. And then the next thing we're going to do is install the hammer. And this is where people get hung up. Grease all over me. People get hung up because what you have to do is you have to ensure that these legs rest in the grooves here and here on the trigger pin, or the trigger pin will walk out. So what you'll do is you'll just lay your trigger in. And what I can do, 'cause I've done it a bunch of times, is I can take my finger and move this around. And again, you can cheat. You can use this pointy pin, and look, it'll retain the hammer. But on this, I have this bolt catch in the way. I can't come from over here and drive my second pin in because the bolt catch is in the way. So I'm going to show one way to do this, and then I'll show another way when I go to the Colt lower. So I'm going to omit using the sleeve. show you is a neat little tool that has been helpful to many students. This is called a hammer cage. K&S makes this. What you do is you take your hammer with the spring on it and drop it in, and you peel the legs up like so, and now the tension's off the hammer. You drop this into the lower, you push your pin in, and then once you're done, you use this tool here that has a little hole. You basically go into the lower and you pick up the leg and then drop it off, and then this will just slide right out. So I'll show you its use. You can see I didn't use any hammer. I just pushed it in, and normally I like to use grease there, but I got ahead of myself. But push, and then once you're about this far in, sometimes you'll run into the other side of the lower receiver. So what I'll do is reorient this. And this is where you can use the hammer's leverage. Just wiggle it until you get things lined up and push with your finger on the other side. Now everything's lined up. Hammer's installed. And we didn't beat on anything. Now if you do have to put any kind of pressure, you would want to use a soft tipped hammer, very light taps, because you don't want the pin to misalign and then take material off the bore of the lower receiver and cause damage. So now we have our cage tool in play. Done. So we have that installed. So now that we've got that in, what we're going to do is we're going to install all the pistol grips and the safety mechanisms. So on this Colt, I want to find the proper safety for it. You can tell a newer Colt safety because it has two sets of detent notches. So I got those mixed up. The reason it has that is you can reverse the safety on a Colt. You can change it over to the right side if you're a lefty. But I'm a righty, so we're going to put this in on the right side. And the next thing we're going to do is we're going to find the safety detent. You want to take a close look at these and make sure that the point looks good. I have some examples here. I have one that's really badly worn. We're not going to use that one. And just to show you, there's always different profiles to them. This one has a little bit of wear here. And these are three new ones. You can see how this one doesn't come to as sharp of a point as this one does. And sometimes you just have to try different detents to see if you get that positive click that you're looking for. So a couple tricks that I use when I'm installing pieces is grease can be your friend. So normally you would put this spring in here. You have your safety installed. You'll take your detent, and again, grease is your friend here because it's hard to get lubricant inside these areas. So if you put a little dab of grease on it, what it'll do is it'll create lubrication for an area that's hard to access, but it'll also prevent the pin from falling out if you have to reorient the lower as you're working on it. And the same thing for the spring here. Sometimes if you're trying to put the grip screw in, the spring will fall out when you try to turn it upside down. So again, little trick, put a little bit of grease, and now it won't fall out. So you hold the safety in. Sometimes you have to work the pistol grip around this lug. You want to make sure that the spring aligns with the detent. Push it on. And before you go putting the locking washer and the screw on there, you just want to check and make sure that your safety feels good, nice and positive. In some cases you'll get a really weak, not a positive click. The positive click can be because the detent just has the wrong profile for the safety, so sometimes you have to swap the safety. Maybe the safety detent area is just out of spec. Sometimes you need to take a safety detent and try a different one that has a slightly different profile to it. Usually the better fire control group kits don't have this problem, but just something to look out for. But let's say this had a really mushy feel and you didn't feel like it had enough tension. Usually it's for one of two reasons if it's not the fault of the safety or the detent. Sometimes the spring itself can be a little too short, and sometimes the hole that is molded into the pistol grip can be a little bit too deep. So what happens is you don't have enough spring tension. So one little trick you can do is, if you believe that that's the case and this won't cause any serious harm, is you can take your spring, and I'm not cutting it, and you take some wire cutters, and I've already done it here, and you can see that I've sort of stretched the spring a little bit. We added just a little bit of length there, and now I want to straighten it out some. You normally don't want to do this with any other spring in the gun. So you can see I've stretched it just a little bit. And that'll give me a little bit more spring tension. So I don't want to put this in like this, because this is a part of the spring that actually moves up and down partially in the lower receiver. So what I do is any area that you have to make adjustments on, put this down lower. So not as much of this can bind anywhere, if that makes sense. So we'll try the one that we did this on. More positive. Better feel. So what I'll do is I'll just put that safety spring in, and with my other parts, and I like the way this feels. So you can tune it a little bit so you get that positive click that you're looking for. Once that happens, again, grease can be your friend here. So if you're dealing with a lock washer, a little bit of grease here will keep the lock washer from falling down. Oh, and it fell down anyway, but I lined it up. I can feel the little bit of the ratcheting of the lock washer working. You just want to snug it up. You don't want to go Superman on it and strip anything out. And then you want to look into the lower And make sure that this grip screw isn't sticking up. And it's not. Give it a good tug, make sure it's not loose. I'm happy with that. I'll move along to the LaRue. You'll notice that when you have the fire control group installed, the trigger sticks up when it's in the fire position. Cock it, it'll go out of the way, and now you can drop the safety in. Again, that feels a little mushy. I'm pretty sure that has to do with the spring tension. For this one, got to do this for the camera. Kink side down into the grip. Much better. No mushy safety. Another trick too, if you're dealing with one of the hex head. So let's say you have just a standard hex head grip screw that the Magpul grips come with. You can take a little bit of grease. If you don't have something that's holding it with a magnetic tip, and you can put a little bit of grease on your bit, and when you put it into the screw, it'll help hold it in place so it won't fall off your driver. A little bit of resistance. Nice and snug. This factory style grip here doesn't hold as well. And again, very, very weak. And again, this is one of the only areas of the gun that you're going to see me endorsing doing any kind of stretching or the like of any spring. Much better. All right, since this doesn't want to stay in place, this can get a little bit more tricky. Of course, I don't have the receiver extension on here either. And it doesn't hurt to put grease on this screw here. You could even put aeroshell, and it's a wise thing to do. You have aluminum on steel. We're not torquing anything, so the aeroshell isn't necessary. But it doesn't hurt to have grease on there. It looks like I'm drunk, but I assure you I'm not. This camera is so difficult to work with. Nice and snug. Very positive. Okay, now we're going to move on to installing the other trigger groups. I'll show a couple methods. This one, again, we don't have the buffer tube installed, so I'm going to do this laying on the table. I'll show some different techniques. So first thing we're going to do is I'm going to show you Geissele's come with these silver pins, which are slave pins. The purpose of those is to hold the disconnect in place. So you put this in here, and then you put the slave pin in place, and that keeps the assembly together. So when you drop it into the lower, and you're trying to put your trigger pin in, you're not trying to get it through this hole, the disconnects hole, and the other hole, and then the other side of the receiver. It can get a little difficult. So what you do is you'll put your disconnect in place. And again, this is another Geissele. And then this is one that is made based on the military training manual. And it's just a cut down trigger hammer pin, the size of a slave pin. That holds everything together. Another critical area with the LaRue and the Geissele, they already put the spring in when you get it. But if you're dealing with a brand new fire control group, sometimes the spring here is not installed. Bolt catch spring and this look very similar. You have to make sure you don't mix them up. So the disconnect spring has a flared end. It's fatter on one side. So if you accidentally use this here, it's possible if you have it in the wrong way, this fatter end will collapse into the bore and never return. And then you have to pick that out of there. Your bolt catch won't work properly. But you want to make sure that you don't put this in backwards here too. So this flared end goes down into the trigger and it contains the spring. As you can see, it's very hard for me to pull it out, so I'm not going to. I don't want to damage it. But if you have to put one in, you're going to have to give it a little bit of a fight and push it in. So our springs are already in place. Going to put our disconnect in. Want to make sure that the spring goes in to that area there. Now we're captured. Now you can put this in here without using this, but it's just a lot harder. We'll take our trigger spring. Install that. What I'm trying to do is get the slave pin to walk a little bit. So I get it lined up here. See, I got it to walk a little bit. Now it's somewhat self-contained. Again, a little bit of grease is your friend. You should just be able to push it through. Sometimes you just wiggle on the trigger a little bit. And out it goes. Trigger's installed. Next, we'll grab the hammer. A little bit of grease. And this is where you can use another method to put this in. So this is where this little pointed slave comes into play again. So push it in with your thumb. And look, it contained it, you know, sitting there fighting really bad. And then what you can do, you can use the hammer as a lever. Wiggle it around till that pin starts. You can see it's fighting me a little bit, and this is where I can go back to this. I can push it a little further in, but it does bottom out, and you can see that I'm not all the way through. So at this point, this is where it's okay to break out a soft hammer if you can't seat this all the way, and I did. I pushed it there. If you'll notice, I'm not seated quite all the way. The reason being is because I'm not lined up over here. So some people will grab a hammer and just start hitting on it. And what they're doing is they're smacking the inside of the fire control pocket and damaging the lower. Again, you don't need a hammer if things are fitted properly. Use the hammer to move it around while I'm pushing with my trigger finger, and I just seated the pin. Installed. One more method. So we'll take the Geissele, we're going to install the trigger spring on it. We've got the slave in here already. Got that pin in. All done with that slave. And then I'm going to show you the other method. So some people will fight a good bit with the hammer spring. Put a little bit more grease on there. So you can use something like this again. But if you don't have something like this, what you can do is you can cock the hammer in some circumstances. Make sure it's on fire. And then it'll actually grab the disconnect and take some of the tension off. Start to push it in. Now at this point, you'd want to take the tension off. Push it in some more. And again, we can use the hammer as sort of a lever. And we're set. You don't want to let the hammer drop repeatedly onto the bolt catch for the lower receiver. It can break some inferior bolt catches and peen things up. It's just good practice to avoid doing that. So now we have these 3 fire control groups installed, what we want to do is a quick function check. So this is a hammer drop lock. You can do it with an upper receiver, but this just allows you to look at what you're doing. And this allows the hammer to fall onto the block instead of hitting metal parts. Alright, so basic safety check. You want to put the hammer into the cock position. Put the weapon on safe. Mash on the trigger. Finger off. Make sure it doesn't drop. It's possible if things are binding and things are worn out or out of spec, when you pull the trigger it doesn't return. See how it returned? And then when you take the gun and put it to fire, if there's enough wear or things are out of spec enough, the hammer can drop and fire. So you always want to do a check with the safety engaged and just finger off the trigger, let it drop. Next check we're going to do is we're going to make sure that the disconnect works. The disconnect is the piece here in the middle of the trigger. So when the trigger's not being pulled and the hammer comes back, it catches on the front sear. But when the trigger is pulled to the rear, the hammer will catch the disconnect. And then when you release it, the hammer drops to the primary sear. That's how it's supposed to function. But what you want to do is pretend that you fired it. Keep the trigger pulled to the rear. Don't let it go. Cock the hammer. And then what you want to do is release the trigger very, very, very slow. And make sure that it releases and catches to the disconnect. And then you should be able to pull the trigger. And we know we're good. What we don't want is a situation like this. So, put it on safe, it holds. Put it on fire, it fires, but watch. Cock it. If I release the trigger fast, everything's fine. But if I release the trigger slow, watch what happens. What's happening is there's either enough wear here in the primary sear area, or there's wear on the disconnect hook, or the hook there on the hammer that the disconnect grabs. Real slow, boom, it went off. Don't want that. Release it fast though, it'll catch. See? Slow. Not good. So, this passes. It's ready to go. Put it on safe. Mash on it a bunch. Good. Fire. Grabs the disconnect. Released it real slow. Fire. One thing you also want to check is to make sure that the trigger spring has enough tension to actually allow the trigger to reset. So this one is pretty tight. If I release it really slow, sometimes, again, if there's any kind of resistance going on here, or if the trigger spring is too light, the trigger won't reset. Now this is also bone dry, and it's brand new. They'll wear in a little bit. Passes. Safe. Good. Fire. Release really slow. Good. And there you have it, 3 different trigger installs. Geissele SSA-E 2-stage, LaRue MBT 2-stage, and a factory, I don't know, 30-stage trigger. A lot of grittiness in them. Factory springs, no aftermarket. Hope you learned something. Hope you enjoyed watching. Thank you.